Hey, there it is. Red light. Red light means go. Of course, I guess when you're driving, it means stop. But in this case, it means go, and we love to see the red light because the red light means that we are connecting with you. Again, this video, A and P students. Hey, welcome back. Thank you for opening this up and getting going. Uh, Man, what a week! Thanksgiving week. You can see down here. This is Friday. Uh, After lunch, or not after lunch, haven't had lunch yet, but will as soon as I'm done here. Non-school week, so don't crawl out of bed as early as I do. I mean, I think we slept. I think it was like 7:15 when we slept in today. So yeah, it was as my grandpa would say, the day's half over, man. What are you doing? But yeah, so don't nearly have to get up. It isn't. It's typically still dark when I get when my work day starts during the regular week. But this has been a great week, man. I hope you're enjoying yourself. Most of us, it's just Thanksgiving, but for one of us, man, one of us got married this week. So hopefully that went well, and the travels went well with that and everything. And can't wait to. Well, I mean, I may not get to hear about it because I told you guys that. As long as you turn in your work online, I'll count your presence. So I may not see any of you again. Well, I guess we'll know Monday at 6, Wednesday at 6, and then won't need to come in for that finals week. Man, it's almost over. Uh, Certainly, in part because this is this is our last chapter, chapter 18, blood, bittersweet. I mean, it's been a great week. But kind of a crazy week. I was supposed to do this on Tuesday, and we woke up to a power outage, and we were out to almost 3 o'clock. It was crazy. No electricity, and so luckily it was warm enough we could do a lot of yard work, and we were just outside, just kind of waiting it out. And finally at 2:30ish, power came back on, but it was work day was already over, so I wasn't gonna try to rush into anything. And man. So, but here we are, chapter 18, blood, last chapter, and because of the cellular respiration stuff not actually being in the book, I mean, this will be, that final will only be over chapter 18 here, so that'll be a big help to you to getting that done. Not that you guys need any help, you guys are pretty smart, but last chapter, man, I'm going to miss making these, and everything, and because the way my class structure is next semester, I won't need to make any video lectures because the dual credit the bio stuff's done, and maybe update them once in a while just to have something to do. But I don't know, need to find me a new video project. Maybe I'll just start doing I don't know. We'll see, but that's not a concern to you guys. So here we are, chapter 18, blood. So let's get into it. As always, got my notes here, and typically I know it's water, but it's Dr. Pepper today. And there's just too much good food laying around. I mean, I'm snacking all the time, and we've been eating pretty good all week between the various Thanksgivings. 4 total. One today. We had one pre. I went to my son's house and hung out with them, and then we got 2 more today, tomorrow, and Sunday. Basically, Sunday's not really a Thanksgiving. Sunday's just kind of both my son and daughter getting in together and just kind of hanging out. So by that time, the food will be certainly non-traditional. Thanksgiving. We're probably ready for some pizza or wings or something non-Thanksgiving-ish like that. But man, lots of good food. Going to my mom's house later on today. She's a Walmart and a Hallmark. She's worked at those places, and so when it comes to Thanksgiving time, ain't no day off on that. So I'll be there today and in daughter's house tomorrow, and then both of them on Sunday. And so it's just a good time, great time. But enough about all that. Hopefully your week has gone super well, and you've been able to relax and enjoy. I know most of you are mothers, or parts of large families, if nothing else. And so there's probably been some big work days as far as cooking and whatever else. But I know growing up it was always a good time. There's a lot to do, but hopefully it's a good time, and you're establishing your own traditions. I know growing up we always enjoyed it. I was oh man, I was really young when we started. Of course, this is back in the 70s when you could tell kids what to do, and they just, I don't know, something crazy. They just did it, and they were worker bees at times. But I know kids are different today. But anyway, yeah, I was potatoes. My job was to get them peeled, get them cut, and get them in the pot and get them boiling. And when they were done, I had to mash them up and until I graduated to get my I was the oldest kid, so once I got my driver's license, then I became the grocery store runner, and oh, we need this, go get that. So I was happy to do that, and but anyway, and then instant stuff started coming along, so maybe back in those days you didn't have to. But I'm going too long on all that, so yeah, we're already 6 minutes in, and I'm still talking about 1970s. But anyway, that's how it goes. So let's talk some blood. Obviously, hey, we got an easy ink pen tray today. We'll go with some red here, although we're not ready for it yet, but we got that selected. So we're simply going to be typing down this direction here, and then we'll start moving to my right, east, whatever you want to call it. And I got 4 pictures over there that'll be associated with notes and stuff. And so, not sure how long it's going to be, but don't tell nobody this, but I did get lazy on the last bit of information because it was a bunch to write out, and the slide had it just perfectly. So I just copied and pasted me the last slide. It's about the ABO blood types, and so you'll get to write it down or take a picture of it, wherever you want to do. But I did get lazy and just brought the slide in as opposed to typing it like I normally do. But anyway, here we go. So let's get us a little box here, and we are going to start off with blood functions. Now you would think now there are some functions that are pretty common. We know that it transports oxygen and around. Of course, it passes when the blood passes through all the tissue. There's part of that also collects the CO2 and stuff, and we know the whole process of when it comes out of the heart, red, because it's got all that oxygen in it, and then by the time it travels through everything and it's headed back to the heart, bluish because it's lack of oxygen. But we're going to see a little more in depth of who actually, I shouldn't say who, what actually is doing that and everything. So it's going to be a pretty good pile of information as far as amount, but pretty important and everything. So here we go, blood functions. We're certainly going to start with, we'll go with this, strong teacher move. And then transport, we're going to go, it's going to be really long if I do it all in one line, so let's go, and then we'll just space over, and we'll go that direction, so you know that this is under transport. But oxygen, and you know how I am about those exponents, and that's going to be CO2 eventually, so I'll space it with a comma. And so these are all things that it transports: nutrients, waste products, hormones, and stem cells. Alright, so we'll click out of that so I can finish that note, so you can make sure you have it right in your notes. Little O2, little CO2, there we go. And close that, come back to this, edit, because we are nowhere near done. And in the second function, protection, nope. And then we'll go down and we'll space over a little bit, knowing that this is under protection. Inflammation. Okay, helps with that. Infections, because it carries all the immune system stuff. That's how it. Yeah, just carries that. Helps with that. Destroys microorganisms. So, I mean, basically it could have been underneath transport as well, because it transports them and then provides those. And let's see, where am I at here? Fights cancer cells. And neutralizes toxins. And little and sign, because it's the last one. Initiates clotting. Okay, then go down, and then the third and final function, regulation. And then we'll go underneath that, space it over a little bit, so you know in your notes that it is underneath that. And we're going to be fluid balance. And it stabilizes the pH. And final one, temperature control. Nope. Oh, got a misspelled word back here. Hopefully you didn't write balance. Of course, hopefully you weren't saying, what's a balance? But anyway, hopefully you knew what it was and did it right the first time. Okay, we're just going to keep going down here. So let's space down a little bit. Blood properties. All right, blood and okay. There's more, but I'm going to just pause right there and say some things. When we went over connective tissue way back when, we covered the blood aspect of that and listed out all of the types and the leukocytes and the neutrophils, basophils, and all that stuff. So you'll have that note somewhere. So if you, when you're taking your test, I mean, to have those pages of your notes also pulled up might be of some benefit when it comes to background information. But yes, we have mentioned if some of this is starting to sound familiar, and maybe not the previous stuff, but this stuff right here, you may be thinking, man, didn't we already say this? And yes, we did cover this way back in what would be your chapter. It would be the connective tissue, and that was part of 3. Chapter 3. No, your chapter 3. Anyway, I don't know. Way too far back. But it is a connective tissue that consists of cells and extracellular matrix. Now the matrix, and of course anytime we say the word matrix, really we're just talking about a collection of stuff. We used that word matrix before when we're talking about connective tissue. It just simply means it's just a collection of stuff. And they use the word matrix because there's just no better word. There's no real word that, like if I go into my wife's a big hobbies, artist kind of person, and I can go in her what would be her pen or pencil drawer, and there's colored pencils, there's regular pencils, there's sketching pencils, there's charcoal pencil, there's all kinds of stuff. And so that collection of pencils could be considered a matrix. If I go into her just junk drawer where she just has all kinds of stuff, I mean, there could be batteries and buttons and thread and other tools and devices, a matrix of junk. Just the word just means collection. And but the matrix is a mixture. And what's the place? There it is. Plasma, RBCs, red blood cells. Yeah, you'll see RBCs, WBCs, white blood cells, but those abbreviations you're well familiar with. And in platelets. Okay, so now we're going to go down a little. Wait. Yeah. Keep a space here. This is still blood properties, but it's a whole different idea. So just know it's a separation, so it is a different set. There are three okay, that phrase formed element, that's just a phrase that is used because there's just not a real word to describe it, but it's simply what we're going to type on here is the three types of things that you can find in blood. And of course, formed element means there's actual structure and it's an actual thing. And when we talk about plasma, again, plasma is a collection of stuff that you'll see, and plasma itself is not a thing, but it's just a bunch of stuff in there. Like, for example, formed element. RBCs would be a formed element because there's actual structure and substance to something. Platelets, but plasma is going to be this fluid with a bunch of stuff in it. But anyway, three types of formed element in blood. And we're going to go down, but we're going to space over just to say that, hey, this is under the previous sentence. Erythrocytes, and of course these are your RBCs, your red blood cells. And again, space over, trying to line it up. Platelets. And of course, platelets are just cell fragments. From specialized cells in bone marrow. I think I got specialized right. Yay me. And then one more. Line this up. And the leukocytes. And these leukocytes, we're going to break them down even further. So leave yourself some room there. because they have two groups. But these are your white blood cells, and again, we broke this down into this separate list. So if you really don't want to write it down again, I can understand that. Just make sure you have that other list in connective tissues back in. And I'm going to have to look that up and see when that, well, that's going to bug me, but I won't do it in front of you guys. That would not be a strong teacher move to grab the textbook and leaf through the table of contents while I figure out something. But the leukocytes, it's got two types. So we're going to go down, and then we're going to go not only over, but over even more to say that, hey, this is under the leukocytes. Now, there are, as I said, there are two types. Yeah, the granulocytes. And these are your neutrophils. Where am I at? Yeah. And your basophils. And your eosinophils. So these are, looks like I'm missing a, yeah, my O before the fills. So essentially, if the leukocyte type has granules, then it's a granulocyte, and it's one of the fills, the neutrophils, the basophils, the eosinophils. So if you're looking at a fill, okay, neutrophil, basophil, eosinophils, you're answering a question about the word, it's got the word fill in it. Do you know it's a leukocyte, a white blood cell, and it's a granulocyte as well. So the opposite of that, and the beauty of science words, is that when they've got a noun and they put things in that category, if there are things that are opposite of that, and they're like, okay, do we need a new word? No, let's just stick an A in front of it, which is what we've done here. And then, so these are without granules, agranulocytes, without granules, and these are your lymphocytes. And monocytes. Yeah, and that is the blood properties right there. So now, let me close this out. And then over here we have, let me slide this over just a bit. There's our next topic right there. Let's just if we make this bigger without getting over stuff. I'll move it. There we go. And then so here are just some examples, like here's your monocytes, which is a leukocyte, an agranulate. Here's your platelets, cell fragments. This is the erythrocyte that we're going to get to. Small lymphocyte, which again is a agranulate, neutrophils. Neutrophils. Oh, there's a basophil. Is there an eosinophil? Oh, there's an eosinophil up there. And so those would be the granulates. And so the idea then is, I mentioned this, but let's just say it again. If it's got a fill, okay, then it's a granulate. And if it's got a site, okay, then it's an agranulate, or without granulates. So granulate, agranulate, agranulate, granulate, and that's not a leukocyte there. Almost caught myself. and leukocyte, white blood cell. So there you go. Hopefully that helps. So let's close this out. Sliding over here. So now we're going to be talking about the components of blood. You know, it gets ran through a centrifuge, and ran through a centrifuge, and so separate it out. And you can kind of see here, if it's at the bottom, that means it's heavier or more dense, and it kind of settles out first, and then it works its way up to the lighter, less dense stuff, which stays closer to the top. So, and the idea of formed elements, that's what we talked about. These are all things, everything in here is going to be a substance to it. It's an actual structure. And then up here, it's going to be more fluid-based. And you can see the percentages here. This is an even 100%, as you can see, but there's more of a range that we're about to identify. So let me get a box here. And we are blood elements. In other words, what's in the blood. And we'll start at the bottom, work our way up here. The erythrocytes, again, these are the RBCs. You can see that's why it's so red there, and you can see the given percentage in the diagram, but a better range is 37 to 52%, and there's fluctuation. I mean, if there's less plasma and more RBCs, then that range will skew just a little bit. If there's more plasma, less RBCs, and you know, the difference in RBCs, you know, that's certainly within a good range, but you know, you can get to a point to where there's not enough, and that can be a bad situation. Then you can't transport oxygen and get rid of CO2 like you need to, and of course either of those are bad in themselves. Of course, erythrocytes are cells. They're made, and they also wear out and get too old or destroyed or break down. So there is a fluctuation in all that. You know, you make a new batch, your percent is higher. You know, you get a bunch that have lived their life and passed away, then your percent could go lower. And plasma is the same way, as you're going to see. It's a collection of stuff. So if you don't have enough proteins in there, you have less proteins or less nutrients, less oxygen, carbon dioxide, that kind of stuff, then it would change that percentage. And then the middle, the buffet coat there, as you can see. I didn't go strong teacher move over here with the little lecture format ends. Okay, the next category is your Wbcs, your leukocytes, and platelets. And that is the same 1%. And again, that's going to be those cell fragments that we saw over here. And we're going to talk some more about those here in a little bit. But your WBCs, that's where your immune system, your lymphatic, I didn't mean lymphatic system, but your immune system, the macrophages, those things that travel around, and they're just looking for foreign material. And if the material that is foreign, you got to get rid of it. So got to get to work on that. And our third and final group, as you can see, that's the plasma. And what's in plasma is a long list, so get ready to go here. But you got water, and you got proteins, and of course, if you have water in something, if you think, and we're going to talk osmosis a couple of times here, but if you think osmosis way back in chapter 2, the idea of osmosis, which is the counterpart to diffusion. Diffusion works whatever the molecule is, it spreads out. I mean, it goes from where it's not to where it is to where it's not, and passive transport. And water works the opposite way. If you remember osmosis, water works to dilute. So if there's a section somewhere that's got a bunch of something, and where water is doesn't have that much, then it goes over there to dilute that. It doesn't move for the sake of moving water. It moves to dilute and dissolve minerals. So your water intake could vary, because if you've got a bunch of salt or calcium or whatever in your plasma, then water is going to come in to dilute that. But if where water is sitting, there's more salt or more of whatever there, then it's going to stay there and not move over. But that's the idea of osmosis. So that's one of the things that could vary the percentages. And we got nutrients. And by nutrients, we could mean sugars, starches, not starches, glycogen. Well, I guess it could be starches if we've just eaten and it hasn't been converted to glycogen yet, or even broken down by cellular respiration, which you just went through. Hope you enjoyed that video, although I'm not going to say I don't know why they got it in there, because it's not a chapter in the book, and you guys just went through that, and no real avenue for or benefit of that, other than just knowledge itself. And we got electrolytes. Well, that didn't come out right. That should be a Y there. That still doesn't look right. Let's glance down here. Plasma list, where are you? Electro and an L-Y-T-E-S. L-Y-T-E-S. Alright. And next up is hormones. And gases. And these gases, as you know, are the oxygen and the CO2 that is transported. And lastly, it's a little and sign. Nitrogen, I needed OUS, nitrogenous waste. Urine and things like that. Well, no, not urine in the blood, sorry, I didn't mean that. But just nitrogen-based waste products. Okay, so now, yeah, we're still in this column, so we're going down a little bit. Plasma proteins is our next topic, and there are three types of proteins found in plasma. First one, albumin, and that's one you may be familiar with, because that's the part that's also like in eggs with chickens and stuff. So you may have heard of it from that standpoint. But it's the smallest protein, but most common. Okay, and what it provides we better go down. Alright, so let's go back and fix our formatting here. And now this one we're going to space over because it's underneath albumins. It contributes to viscosity Hopefully you're familiar with what that word means. But we will be talking about it. It's got its own slide as well. Both of these two words in the Osmolarity. Yep. And the albumin influences, or I'm going to put effects. I got no chance of spelling influences. Affects blood pressure. Okay, our second type of protein is the globulins. And they are important because they're part of that ABO blood type and the antibodies and things like that, which is a big word right now. We're about to talk about the ABO blood type here in a little bit, maybe 20-25 minutes away still. But the word antibodies is pretty big right now, and it's in the context that I deal with it, it's like it's a negative. It's one of the things that obviously are tested for in the coronavirus, and if you are found to have those, you can get quarantined to some degree, or it can come up anyway. And so, which in the students' eyes and my eyes, I mean, that's a bad situation. But they're helpful, as you guys know, with the immune system and everything else. To have the coronavirus antibodies means that your body is equipped to now fight the coronavirus, which is a good thing. But if it's detected that you have them, that in itself could be a bad situation, because now you may be subject to shutdown, which nobody wants that. So that's just an interesting take on something that's good to have, helpful to have, but by having it, it can be a personal negative. Let's see, and of course we've already mentioned this, but this provides immune system help, and it's a part of making the alpha, beta, and gamma globulins. Okay, and our last, let me close this out. See how much I got. I got 2 more lines. Yeah, let me close this out. Scoot up just a little bit here and get back in here. In our last type of protein, the Fibrogen, and these help form blood clots. Okay, and then I'm going to go down, and I'm going to come down one space here. This is a note that kind of contributes to that, but it's not a part of the 3 types of proteins. But all these proteins formed in the liver, or I'm going to come back and identify, but I'm going to get the whole note out here, plasma cells. Alright, so let me clean this out, and the ones that are, okay, so in the liver, let's do it this way. Liver, and the globulins are made in the plasma cells. So however you want to identify that in your notes. If you just want to write it out, that's fine. If you want to draw arrows like that, that's fine. That's completely up to you. So while you're deciding that, I'll turn over the page. As Bob Seger once said famously. He didn't say over, he just turned the page. Alright, so now, and we're not quite to this diagram yet, so we will scoot this. Oh, I gotta close my ink tray out there. Move this up, and we'll just start us a new box right here, and we got a little bit more to type. And then we'll get to the erythrocytes, which is over there. And actually, that needs to be beside, so I'm going to have to move those over so you can see the picture and get your notes at the same time. So we're continuing the idea of properties of blood. Okay, and now we're going to talk about those two words, these two words right here. But viscosity, okay, this has to do with thickness. Okay, how quickly blood flows. Now, when you think of the word viscosity, I mean, we got to talk about this. We talk about this in physical science. We talk about this in chemistry. We talk about it in biology. You can have high viscosity. You can have low viscosity. And neither one are right or wrong. It just depends on the situation that you are in. If you think water, okay, if you're pouring water out of a glass, that's low viscosity. It flows pretty quickly, pretty smoothly. I should have mentioned earth science when we talk about lava. But if you think motor oil, okay, or molasses, okay, that is high viscosity. Okay, so it's thicker, doesn't flow very fast. So if you're in an earth science situation and you're dealing with a volcano that has erupted and the lava is moving, if it contains more of the minerals that are less dense and it's moving pretty fast, like the Hawaii Island volcanoes where it's just watery stuff just flowing out of there pretty quickly. But if it's coming out of a mountain, it typically has high viscosity, which means it has got a lot of heavy minerals, iron, that kind of stuff. And but viscosity can be high or low, neither are right or wrong. It's just descriptive words, and based on your situation, if you need to have low viscosity but have high viscosity, that's a problem. If you need to have high viscosity but have low viscosity, that's a problem. So neither are right or wrong. It's just the situation that is needed at the time. And the other word that we dealt with back then is the osmolarity. And if you're a chemical person, the word molarity just jumps out at you. But that's simply the word that means concentration or amounts. And let's see, where are we at? Okay, so the osmolarity just refers to the concentration of dissolved particles that cannot pass through the blood vessels. In other words, they are stuck in there, and when the blood looks to go through, or no, they're just inside the blood vessel, they can't get out. And so, things like glucose, that's a big molecule. Okay, oxygen can go in and out at will. Carbon dioxide go in and out at will. That's how you transport it. It's how you get rid of it. It's how you pass it along. But something like a glucose or the proteins, they cannot. They're too big, so they're just in there. And if that is a high concentration of that stuff, then that's going to cause some changes or some things to occur. And if there's low concentration, that's going to cause some things to occur. And that thing that's occur, again, is we're talking osmosis. I haven't done any of my, go back up here and fix these, but hopefully by now. Alright, so we're talking osmosis. And we've already had a little bit of osmosis review, but okay, so if the concentration is high, water moves in. And again, a reminder, it moves in because it's trying to dilute the concentration down. Where water is at, okay, has a lower concentration of whatever's in that blood. And so therefore it's going to go, all right, some of your water go over there and try to dilute that down to make that an even distribution. Water moves in, and this is going to increase blood pressure. So if we're going to increase blood pressure, especially if it's to a level, okay, that's too high, when you take medicine for blood pressure, and you guys probably know more about this than I do, it's just from your careers that you're in, then one way to combat that is to make sure that you monitor what's in the blood and can deal with that. But if the concentration is too low, concentration is low, then water is not going to come in. It's not going to need to loop that down. Where it's at has a higher concentration. It's going to say, well, we're going to stay here and keep this under control because that over there doesn't seem to be a problem. But when that happens, and now I'll just spell it out. Okay, that's going to lower blood pressure, and if it lowers a high number, that's fine. Okay, that, you can understand how that's fine. But if it lowers a good number or a number where it's supposed to be, then that's where we're in, could be in trouble. Or if it lowers an already low number, that's even a worse situation, which they obviously have to deal with that. All right, so that ends our overall properties of blood. And now we're going to scoot over here, and as I mentioned, that's the one I took. That's one I cheated on, and just typed it all, or just brought the whole thing in. So we're going to move this over so we can type right in here, because we're going to be talking about. So really, we got two. Well, you've got 3 sections. I got 2 sections. While you're writing all that stuff down about the ABO blood tests, I'll be talking about it. But you can certainly just pause the video, write it all down, and listen to me ramble, or just say, he's done, I'm done, let's go. Alright, so we're going to talk now about the RBCs, the erythrocytes. Give me a text box here. But we are dangerously close to being done. We get done with this list, and we'll be of what's left. 90% of what's left is right here in this list. It's a fairly long one, but here we go. Okay, the RBCs, the erythrocytes. And I'm going to go down here and put my first deal, but then I'm going to close it out. And then I'm going to draw me a line so you know that that's what we're looking at over here. And we'll edit that. And, okay, our first thing we want to recognize transports, and I'm just going to put gases, but just recognize when I say gases, I'm talking about oxygen, I'm talking about CO2, but the idea of typing the O's and the CO's and writing the 2's, you can do that in your notes, but we've already identified it a couple of times already. But when we say transport gases, we're talking about oxygen and carbon dioxide. It is a disk. Nope. Okay, the thick rim, and you can see that over here, and that's the classic shape. And of course, when you get that sickle cell and it's shriveled up on one end and it just doesn't fit the mold, and plus it gets, if you took this in and push it in, that's going to expand the length, and that's part of it. And of course, you can see the cross section there, and what am I drawing a blank on the nucleus for? Yeah, as I say, it just didn't seem right. What am I doing here? EUS. Yeah, that's a word I spell all the time. I don't know why I draw brain miscalculations on that one. But yeah, it lacks mitochondria and nucleus. Doesn't have all the organelles. These cells, come from other sources, and so, and they're just transport vesicles for the most part. Don't need to make their own energy. Don't need to have their own DNA. I know we talk about all cells have that stuff, and that's probably a misnomer. But these aren't cells in the true sense of the word cells. They're trying to become a bigger thing. Like heart cells are trying to become heart tissue, which makes the organ. Muscle cells are trying to be muscle tissue, which then makes the whole muscle. Red blood cells, that's the end of the road. That's all. They're not going to be part of this huge other thing, and so they don't need all those organelles in that sense. And next up for us are blood type, as in whether we are A, B, AB, or O. And the glycolipids, and these are things that we talked way back in plasma membrane days. Those are those little green squiggly things that are up there. They're part of the receptor process as well. Molecule recognition. Can you come in? Can you not come in? That kind of stuff. And next up, okay, the cytoskeleton proteins. In other words, proteins within the cytoskeleton. Okay, give it durability. I mean, red blood cells pass through a lot of tissue. Okay, and they got to be pretty strong. I mean, they got to have some resilience and durability. I mean, if you just think about truck tires that always are traveling on gravel roads or fields or off-road material, they're not on smooth pavement. And our red blood cells don't travel on smooth pavement. I mean, they're going through tissue all the time, picking up, dropping off, all that kind of stuff. They work hard, so they got to be pretty durable. And the cytoskeleton proteins allow for that. Moving down our list here, 33%. of the cytoplasm of a red blood cell hemoglobin, and as you know, that is HB. And we're going to talk about hemoglobin here in just a couple more lines here. Oh, matter of fact, right here. And when we have the RBCs and its percentage of hemoglobin, those two numbers determines, oh, with my R out there, determines how much gas transport the blood can do. And next up, and this is our last one, as far as nutrients, needs iron, vitamin B, no, B12, vitamin C, and let's see, folic acid, and copper. To make new cells, so you got to have those things. But we know how much how much iron is important to us, and certainly know B12. I mean, I had an uncle that was B12 deficient, had to take those shots and stuff, and of course vitamin C, and so you just got to have those things. And when you don't have them, okay, it's not great. All right, and of course this was a picture, and so now we close this out and we go over here. Let me do it the other way. Let me go above, because what I'm gonna put above goes first, and then this. So let's get this little text box, and this is our last. Oh, I didn't mention this was a two-parter. Yeah, this is a two-parter. So we're about to wrap up part one, and you might be, since I hadn't said it, you might be thinking, oh, is this it? Is this it? Is this our last one? Well, it's the last one of the first one. So let's talk about blood. Blood antigens and antibodies. Now we'll type this, but we'll just say it aloud first. The antigens are what you're born with. Okay, the antigens are the things that determine what blood type you are, and you've got your blood cells, and then you got these little antigens that kind of connect to them to say, hey, we're A, hey, we're B, we're AB, okay, we're O. And then the antibodies are going to be the opposite type. So if you're A blood type, you're going to have B antibodies. In other words, if you are given a transfusion of the opposite blood type, A or B, whichever you're opposite of, that's a bad deal, and really bad deal. And why it's a bad deal is because it clumps up. Okay, it clumps it up. And so it doesn't pass through the arteries, capillaries, at all, and so it clumps that up, But also, if it's the opposite type, it's going to be marked for destruction, and then your immune system are going to come in and start destroying those. And so that's a bad deal if a big portion of your blood cells are taken out. So when blood work is involved and you're getting blood, man, it's got to be done right. You can't just eyeball that one, as my wife would say. Actually, I said it backwards. She's an eyeballer. She eyeballs everything, and it's like nothing is measured out, and I'm like the exact opposite. But anyway, that's enough of that. All right, so blood antigens. So as I already said this, but an antigen is a complex molecule on the surface of a cell determines self. I'm going to put the word unique. Now when we say self, we're talking about each person on their cell surfaces has a collection of molecules that are unique to you. Okay, and that's how your body knows when something foreign shows up. You can think of it back in the 1600s and medieval times in Europe, when a country or a kingdom had a particular symbol, that's on their flags, maybe on their soldier shields or on their castles, wherever. And anything that was a part of that flag or that shield, that was us. Okay, but when another king or somebody from another country showed up with a different flag, that was easily identifiable that that's not us. Okay, and we got to determine what their intentions are. Your blood's the same way. Well, I'm sure you can hear Avery. Some big truck, whether it's a UPS or the mailman might be here, who knows, pulled up outside, and every day for 8 years now. Avery's 8 years old. Whew. 8 years every day, the big truck pulls up. We got to sound the alarm because the Lord knows it's about to go bad. When the mailman stops, puts the mail in the mailbox, and then drives away, or the UPS guy. So when she's outside, it's even worse because it's hairs up. It's death. It's, man, do not come into my yard. And they joke about it. If you see them around town, you can, first couple of times it's like, hey, how'd you like my dog today? She's like, oh man, she's crazy. Yeah, she's something else. All right, so it's gone now. The thread is over. All right, back to antigens. Unique to ourselves, and that's how the situations when transplant people have to go through, like we do here, where you've got to battle that. And of course, that's a bittersweet kind of situation because you are extending your life by reducing that immune system battle, but you're also making yourself vulnerable to other things, and that's one of the things that's with this coronavirus, and certain people are more susceptible, or I should say, it's more of a danger, and she'd be one of those. So with the lung transplants and stuff, so we've had to really be careful with the coronavirus stuff, and hand sanitizing and gloves and keeping my distance, and basically just hosing down as much as possible. So yeah. All right, and so enough. Moving on here. So then antibodies, which are determined by conjunction. So if you got A antigens, you're going to make B antibodies, and vice versa, as you can see down there. All that stuff that I didn't want to just redo on my own. But these are proteins. okay, that mark for material for destruction. So, in case of my wife's lungs, I mean, when when the macrophages see that, they're like, "Hey, that ain't us. We got to get after that." But you don't want that to happen. So, it's a bittersweet wasn't the right phrase, but it's certainly a delicate balance. Hey, maybe that's the right word to use. And last thing for me here, regulation. Oh, it's right here. I can just be looking at it. Inogens. I'll make sure I spell it right. Leukocytes. Yep. And this is when the antibodies, in other words, the markers, antigens, in other words, got those backwards. In other words, when your antibodies bind to the antigen to say, hey, that's not us right there. Sound the alarm, get the macrophages over here, get the leukocytes over here. Let's take care of this. Immune system alert. All right, so there we have it. And of course, this is the last for me. And of course, but just recognize that you need to get this stuff as well. And even though I chose not to type it all out, and so on and so forth, so be sure you grab that. But it's pretty straightforward, and you guys know enough about this just from just living, that if you're a blood type A, you've got to have A, and you're going to make B antibodies. In other words, so if you were given type B blood, your body would go to work and say, no, we can't have that in here. And if you're a type B person, opposite, you're going to make A antibodies, and you can't get that. But if you're an AB person, you've got no antibodies, you've got both A and B antigens, so you're good. Okay, and then of course the type O people, universal donors, you can see, and then the rare, the type AB, you can be, if you're type O, you can be you're that donor that everybody wants to get. If you're AB, you're the recipient, you can get a lot more options than most people. But hey, grab those, and hey, again, enjoy your week, man. We are almost there. I got another video I got to make it tomorrow, because I think Sunday. Yeah, Sunday I said we're going to try to spend the whole day somewhere. But get this done, get myself on the road here after a bit, and same thing tomorrow. So I'll make it to again tomorrow, the 28th, and man, then we'll be done as far as lecture videos, and as far as meeting in class, we may already be done. Because Monday I'll put up a little something over chapter 18. I'll do it Sunday, and same thing for Wednesday, just questions. And if you come in, you come in. If you don't, you don't. And as long as I can see the assignment, I'll count you present. And then the finals the next week, and again that'll be online. So again, just kind of everybody present, and assume everybody's going to take it, and go from there. But hey. So with that, hey, we'll get out of here. We'll save the fancy goodbye for the next one, and see if I can get through that. I'm not great at don't act like it, don't seem like it, but pretty sentimental with a lot of stuff. So who knows? Some days sometimes they're smooth, those final goodbyes. Other times they're pretty shaky, and we'll see how it goes. And sometimes I just gotta get done and get out, because I know it's gonna go bad for me. But anyway, hey, again, thank you for opening this up. Enjoy yourself the rest of your break and the rest of your semester. And say it again, but hopefully someday down the road our paths cross and I get to hear all your updates and everything and how things are going. And with that, we will say goodbye.